Hi everyone, my name is Nathan Martindale, and this is my colleague Jacob Smith. So we're from Oak Ridge National Lab over in Tennessee, and throughout this week there have been multiple tutorials, multiple talks about IPyWidgets and widget-related subjects. And so here's another one. So we're going to talk a little bit about some of the benefits, some of the limitations of IPyWidgets. We'll discuss some of the ecosystem, some of the community that's developed around IPyWidgets. And then finally, we'll talk about a library that we're working on that we've open sourced that introduces some new mechanisms to allow a certain type of interactivity inside of Jupyter. So with that, Jacob will introduce the subject and we'll dive right in.
All right. So I wanted to start the introduction by talking about a correlation of sorts between a few different topics in the world of data science. So we, as the data science community, I guess, I know we're in the playing nice track, but we're trying to solve more and more complex problems, which typically require complex data sets, and then we build these complex models to help us gain insights from the data sets in order to solve the problems. All right, and one of the issues with all of this is it becomes increasingly more difficult to have an intuitive understanding of what's going on under the hood. So not only is there a correlation between the complexity of problems, data sets, and models, but by extension, there has been a lot of effort going into the development of interactive tools in frameworks in the Python visualization ecosystem. Why? Because we need to be able to understand and interact with the data and the models, because we're not going to use models that we don't trust and we can't gain insights from data that we don't understand. Right, so it's awesome for all of these tools in the Python visualization ecosystem to exist on their own, but the beauty of it all, and again the theme of this track, is they typically all work really well together. And more specifically for us, they play nicely together within a data science workflow. And the growing standard for a data science workflow seems to be Jupyter notebooks. We've seen them all over the conference. Pretty much every talk that I've been to uses them in some way. But that makes sense, right? It's a place where documentation, code, and analysis can all coexist. And that's an important note for us, because the tool that we've developed only works within Jupyter notebooks, or it's probably more correct to say that we've only tested it and designed it to work within Jupyter notebooks. I'm sure there's a workaround. Okay, but all of this I'm trying to build up to our use case. So what you're seeing here in the GIF is a UMAP of the embeddings for a seismic data model. And what we wanted to do in the beginning, what kind of conceived the idea of all of this development, was a simple idea. We wanted to be able to click inside of any of the individual clusters and show an additional visualization on top of the underlying widget that has more information about the cluster that we're interested in. Right, so we wanted these widgets that appear over top of the other widgets. We want them to have a few things. It needs to have a title so you know what you're looking at. It needs to have a closeout bar so you can kind of explore interactively. We want it to be able to move around, and we wanted to be able to right-click, have a context menu, and show us exactly the exhibits that we're interested in looking at in that given time. So as we were trying to do this, we found that it's a largely unsupported interaction paradigm in Python, at least. So that led to the development of our library called IPyOverlay, which allows rendering widgets on top of other widgets. So why is this important? Well, for us, it adheres to the ideals of this overall design approach to interactive visualization, referred to as details on demand. And this comes from a paper written way back in 1996, so nothing new, but the mantra of This design approach is overview first, so to get an idea of the scope and scale of your data at large. Zoom in and filter to what seems the most interesting from that view, and then from there you can dive into the details that you're most interested in. And what this allows for is a flexible user experience. So what I have written here is a description for that is the ability to selectively go in depth without cluttering the interface or interrupting the workflow. And the little colored blocks that I have here represent the standard kind of design format for a dashboard. So what I mean by cluttering the interface is in the green block, you have the main visualization that you're trying to look at. And if you're not going to have pop-up windows, then you need to have pre-existing exhibits that kind of exist around that. So that's what I mean by cluttering the interface. But also, as a side note, by having pre-existing visualizations, one could argue that you're biasing the user. You're biasing the user by kind of showing up front what you think that they should be looking at, which of course there's a time and a place for that. That's not inherently a bad thing, but in our case we kind of wanted to avoid that. And what I mean by interrupting the workflow, if you think back to the example we were just looking at, wanting to click on two different clusters and kind of compare the statistics of what's going on within those. If you wanted to do that in this design format, you'd have to click on one of the clusters, populates all the surrounding exhibits, click on another cluster, kind of go back and forth. Of course, there's workarounds for how to do that without that, but it seems to make sense to just let it show up in a pop-up window, right? Then my last note here, this is a long-standing technique. We're not inventing pop-out windows or the idea of details on demand. What we're trying to do is just bring an easy way to do this within Python, right? So with that, Nathan's going to talk more about the current widgets ecosystem and where we think we fit within that.
All right, so we'll go ahead and dive in. So IPyWidgets, for anyone who hasn't been to some of the other talks, or maybe for anyone who hasn't used them before, IPyWidgets are one standard, one way of enabling user interactivity inside of a Jupyter context, so either Jupyter Lab, Jupyter Notebooks, things like that. And it does this, it allows you to do all of this within Python by providing different input and different output widgets. And so what that means is input widgets would be maybe your standard HTML form elements. You can see an example of that at the bottom left here. So this would include things like buttons, text boxes, sliders, things like that. And then output widgets basically gives you a place to render anything that could normally be rendered as the output of a Jupyter cell. And so where some of the power from this comes in is that you can attach your own code, your own event handlers to run when inputs from these widget values, when the input widget values change. So for instance, when someone has clicked that button, when the text in the text box has changed. And so what this allows you to do then is in your analysis workflow, you can create these sort of ad hoc interactive analysis tools, these dashboards that you can play with in real time, and again, within the same notebook. And so just as a very basic example, you can see on the right here, this is just a function that's plotting a sine wave in a matplotlib figure. And as we change that slider, that automatically updates the figure that you're seeing. All right, so what's so great about IPyWidgets? Why is this important and why is it a valuable library? There's sort of this fundamental challenge that we have here. There's a separation between the browser, where you're actually interacting with Jupyter, the web application, and then the IPython kernel that's running under the hood, where your actual Python code is running. And so this is really where the playing nice aspect comes in. We need these two different ecosystems, the HTML, JavaScript, and CSS of the front ends, to be able to talk nicely with the Python in the back end. And so this is what IPyWidgets is providing. It's giving you this sort of bi-directional communication channel between these two components. More specifically, it's doing this through a form of state synchronization. So essentially, you can have variables data that's in your Python backend, and anytime a change is made to one of those variables, that can be automatically synchronized to an equivalent variable in the front end, and then vice versa. So you could think of the value that a slider is at will be transferred between the two sides. So for the nerds in the room, this is technically an MV star framework, not an MVC, which confused me for a while. But the important thing to note about this is that there's two main components. There's the model, which is the data that you want to synchronize. So again, that could be maybe the value that a slider is representing. And then the view, which is it's the code defining how you render a particular component based off of the data in your model. So where to show that the slider within the slider track. So there's a diagram here that shows those communication channels in a little bit more detail. I think the takeaway here is that IPyWidgets is sort of providing a common framework that abstracts away a lot of this very messy communication, and it allows you then to create even custom widgets. And in theory, you just, quote unquote, just need to define that model, that view piece. And so as a result of this, the ecosystem has been able to flourish because people have been able to build libraries that either integrate with widgets or are providing new widgets to the community. So IPyWidgets by itself does have some important limitations that I want to talk about, because I think this motivates why we have some of the other libraries in the ecosystem and why they're important. The first is that with just base IPyWidgets, there's a fairly limited set of input components that you can use. Again, you can think of, these are generally your typical form elements, but fancier things that you might want to be able to input are not necessarily there. So, there's no dialog windows, no floating buttons. A use case that I frequently run into is interactive data frames. And then even beyond that, the set of events that you can listen to on these widgets is also fairly limited. And it's important to keep in mind that when you're working in any sort of a UI context like this, the code here is generally very events-driven. So what determines what you're able to do is the types of events you can listen to, what you can listen for. So what sorts of actions can a user take that triggers some of your event handling code, for instance. And so with IPyWidgets by itself, most of these input components can really only listen for value changes. So this excludes things like mouse events, focus events, or really even raw keyboard events. And all of those, the ability to listen to many of those types of things can improve the types of interactivity that you can add into a dashboard. Another aspect that is limiting in IPyWidgets by itself is there's some pretty hard limits on what sorts of styling and layout attributes you can add to these components. So for instance, if you want to do something like overlay a widget on top of another, there's some very specific CSS rules that you need to be able to add to incorporate that. And with the base IPyWidgets, that's very difficult to do. Finally, one of the limitations, one of the very important limitations of IPyWidgets is that building custom widgets is very complicated, very involved. It requires, you're essentially building both a Python and a JavaScript project in the same folder, in the same directory. So you need the infrastructure for both, you need tool chains for both. If you've never had to deal with JavaScript build tool chains, that's a very good thing. I encourage you not to go down that route if you don't have to. And so, the main takeaway is that there's a pretty substantial amount of boilerplate that comes along with trying to build one of these widgets from scratch. And actually, previously, the official way of doing this, you had to set up your project using this Jupyter-provided cookie cutter, which would build out all of those default files for you. And so, the problem here is that it's very difficult to quickly prototype a new widget within the same project or even within a notebook or something like that. For anyone who attended the AnyWidget talk yesterday, they were mentioning very similar things. So moving beyond just base IPyWidgets, though, there are a lot of other libraries in the ecosystem that address many of these limitations. Informally, I like to classify these libraries into three general categories. There's so many libraries that it would take many slides just to list all of them, but there are many libraries that incorporate new widgets. So for instance, some obvious ones would be IPyMPL. It adds interactive matplotlib figures. You've got Plotly, Altair, mainly any type of visualization that you might want to include. There's probably a widget library for it out there somewhere. There have been a bunch that have been mentioned just at this conference. If anyone went to the Lawnboard talk, that's an excellent example of this. There's also another class of libraries that integrate with IPyWidgets that can assist in dashboard construction. So things like Panel, things like Solara and Voila. These don't necessarily provide novel IPyWidgets, but they allow you to remix them in different ways. And then a particularly important class is the set of libraries that entirely change the workflow for how you build new widgets. Again, IPyWidget is a fantastic example of doing this. It makes it substantially easier to build custom widgets. And then there's also two others that I want to talk about, IPyReact and IPyVuetify. So IPyVuetify we're going to focus on a little bit here just because we found it to be particularly useful and by itself addresses a lot of the limitations mentioned. There's a lot of terminology on this slide, a lot of JavaScript nonsense, but briefly, Vue.js is a JavaScript front-end web framework. Its main emphasis is on build a very component-driven design. So you can build a component in a single file by specifying the HTML, the CSS, and the JavaScript all sort of in the same place. Vuetify then is a very large set of pre-made, very nice-looking, pretty material design UI elements that are all implemented within Vue. IPyVuetify then, to sort of wrap all of that together, is a port of this library into IPyWidgets. And so the takeaway there is that it lets you use Vue components like you would a normal IPyWidget within Python. You can see an example of some of these in the figure here. So the way that it actually addresses some of these limitations is, first of all, for all of the default components that come with IPyWidgets, IPyVuetify has a corresponding version. You can see some of the examples in the lower right comparing them, as well as many widgets unique to IPyVuetify. So for example, it comes with some very nice interactive data frames, which again you can see in the bottom right here. For the events, it addresses this by any of the normal HTML events that you would be able to listen for inside of JavaScript. It incorporates that, again, on the Python side, as well as for many of the unique widgets, they provide their own specialized set of events that you can listen for. This would be things like specific row or cell clicks within an interactive data frame. And then finally, it gives you full control over the inline CSS if you want to go embrace full chaos. So finally, similar to any widget, IPyVuetify makes it much easier to build custom components, makes it substantially cleaner. Essentially, all that is required is a Python class where you define the variables that you want synchronized between the front end and the back end, and then either a Vue file or a string of Vue code, which again is that combined HTML, the CSS, and JavaScript. And Vue.js specifically lends itself well to reducing some of the boilerplate that can often be associated with this. It has things like watcher functions, which make it very easy to automatically listen for changes to specific variables in your Python class. And again, one of the main draws, one of the main appeals for this is that you don't need any of the JavaScript tool chains for this. This is something that you can test, you can prototype directly inside of your notebook or in another file in your project. All right, so getting now to IPyOverlay. So again, this is a library that we're working on. It is still somewhat early development, just a heads up. But we've open sourced it. You can take a look at it at the GitHub link below. So what IPyOverlay is doing is we took advantage of IPyVuetify and built on top of it a set of custom IPyWidgets, which we sort of refer to as wrapper components. This is sort of a BYOW situation, to bring your own widget, where you provide a widget and use one of our wrappers, and that wrapper enables some of these details on demand interactions that Jacob was talking about by supporting the ability to render these widgets sort of with this arbitrary and controllable positioning. And so this allows some of the functionality that you see in these GIFs here, primarily things like click and draggable overlay windows that can contain any other IPyWidget. So what was the challenge here? Why is a library necessary for this? Why is this difficult to do within IPyWidgets itself? Most widget layout systems tend to be organized around a form of grid layout. Again, for the nerds in the room, generally this is done via flexboxes and CSS. And so you generally have something like what you see on the left. You have your widgets organized into nested rows and columns, H boxes and V boxes for IPyWidgets. And so that's generally speaking what you're going to want. It makes it very easy to have nice, clean, stacked layouts. If you want to embrace the chaos, like what you see on the right, if you want the ability to render a widget on top of another, you have to take advantage of some of those specific CSS rules that allow you to do some form of absolute positioning, where you're you're specifying the left and top pixel value distances for any given widget. And so that's IPyOverlay's main contribution. We take advantage of IPyVuetify's ability to nest any other IPyWidget, one that you specify within your Python code, and that's the entire widget is something that can be synchronized. So that allows us to wrap any widget that's provided with custom CSS, custom JavaScript. And so we provide a couple things. First is the overlay container, which is the blue box in the bottom right. This is sort of the container for anything that you might want to have overlay widgets on top of. So this has a background widget. This could contain your normal grid layout maybe of multiple plots, anything like that. And then you give it a list of a dynamic list of overlay widgets, or things that you want to be rendering over top of that background widget. And so the widget wrappers then are some utility wrappers that give some basic functionality that we think is probably fairly common to want to use. So you can wrap any of the widgets you want on top with either our widget wrapper that adds the click and drag functionality, ones that add the little decorator title bar, so on and so forth. Another feature that we added is this idea of connection lines. A problem you can run into is if you've opened a bunch of these different overlay windows, it can start to become dissociated from the underlying data. So if I were to open 4 of these floating windows, it can be difficult to remember, okay, which cluster were these supposed to be referring to? So inside of the overlay container, it can render connection lines, which these are optional, but you can then you can connect that widget to a particular point within the background widget. Now, it's one thing to say, hey, I want this overlay widget to be associated with a particular pixel in the background, but a challenge here is what if your background is dynamic? So if you've got an interactive matplotlib figure, you can pan around in it, you can zoom, and so that one end of that connection line needs to remain updated. The annoying part here is that the ability to do this is different for every visualization library. So far we only support this in IPyMPL and Plotly. Main problem is that you have to find a way to hook into some of those events that are being generated by those individual plotting libraries to tell that something has changed in the background. This is something that we intend to continue expanding on in the future. And finally, we have context menus. This is a paradigm that is common across most computing platforms. Most desktop operating systems, most phones have the ability to have this sort of right-click menu. And this very much fits within the details on demand paradigm. You're hiding specific actions that may be context dependent or position dependent until the user specifically requests, hey, I want to take some action at this point. This again was something that there's not really an easy way of doing this directly within IPyWidgets. So in IPyOverlay, we have a context menu area wrapper. So if there's a particular widget that you want a specific set of options, specific set of actions to take, you wrap it in this context menu area and then specify the set of options and event handlers to use. So to wrap up, IPyWidgets, this is a very useful library for building sort of ad hoc interactive tools and dashboards within Jupyter. It has limitations, but a lot of these limitations are addressed in various other libraries within the interactive visualization and widget ecosystem. IPyVuetify is a library that we've focused on quite a bit. We've used it a lot, and it's been very useful for our purposes. It by itself provides a pretty large set of interactive components you can use and makes building new widgets from scratch very easy. And then IPyOverlay is a library we've open sourced that we've built on top of IPyVuetify. Its main contribution is to provide some of these details on demand interactions by allowing widgets to be rendered on top of others, allowing overlay UI elements, click and draggable windows, and things like context menus. So with that, thank you all for coming, and I'll take any questions.
Thank you. Questions? Yes.
Thank you. This was really great. I love all of this. I think maybe this is too broad of a question, but In the scientific Python community, we have lots of people who do things like, optimize code and, make things vectorized and whatever. But we don't have as many people or as much effort going into things like this, like user experience, user interface design. Like, how do we as a community value that more and make these kind of things more common and easier to use and all these kind of things?
Sure, that's a really good question. I also have a bit of a soapbox about the importance of good user experience. I don't know that I have a great answer for how broadly we do this, but I will say I think this week as a whole, this conference has been really interesting to me, and it's been very heartening to see how many different talks there have been about these widgets. I think with some of the work that IPyWidget has done, the ability to make it easier for people to build and construct new widgets, I think it simplifies a lot of the effort that needs to go into people contributing new types of widgets, new types of experiences to the community. So I feel like we're on a good trajectory. So I think, and if anyone went to the IPyWidget talk yesterday, Trevor was also demoing the Quack library, which was a absolutely fascinating interactive data frame visualization. I think more people demoing stuff like that, I think gets people excited about being able to incorporate that sort of thing in their own tools. So I feel like as that starts to progress, I think we'll start getting more towards better user experience design.
Thanks a lot. It was an amazing presentation. I really like this floating widget that connects to the underlying figures. So far, you showed 2D graphics. What about like 3D graphics that are interactive? Should the backend, the plotting library, implement something that matches the pixels so you can point the floating, or how could be that? Is it supported?
That's a really good question. We have not explicitly done much with 3D visualizations yet. The closest we've gotten is as part of our dashboard, we were playing with maps inside of Plotly, so map visualizations. And it's got the ability to sort of pan in 3D. And so the way that we were able to incorporate the connection line, keeping up to date with however they had currently panned it or rotated it, was essentially through hooking into their JavaScript and registering on the JavaScript side our own event handler to, oh, hey, when they've updated that, use whatever their current projection is set to. It's a little bit janky, and that's kind of one of the issues here. And I suspect it's going to be dramatically different for every library that we try to support that for. So I don't have a good answer beyond that, other than it probably just depends based off of the visualization library itself.
Thanks, this is really cool. I realize that this might be opening a can of worms, but I'm curious whether there has been any effort across these different visualization libraries to come up with like a protocol that anybody can implement. Because, everybody, I'm quite experienced with Panel, I'm less experienced with IPyWidget, but it just seems like every one of these libraries is like slightly different in a way that makes it very hard to integrate with other ones. And if there was like a protocol that you could implement, then I think it'll go a long way toward, making that intercompatibility like a real thing.
Yeah, that is a very good question. I don't know specifically. One of the reasons that I appreciate Panel as a library is that I think it does a very good job at integrating a bunch of different visualization ecosystems. I don't know that there's necessarily a protocol standard behind that, though. So there's no protocol that I'm aware of. Beyond that, I feel like IPyWidgets itself is probably the closest we have, just because, again, it's abstracting a lot of the WebSocket and message queuing type stuff, so that people developing widgets don't really need to worry about that aspect of it. That's the closest thing that I'm aware of to that. But that's a very good point.
We have time maybe for one more question. Okay, then let's thank Nathan and Nathan. Thank you.